Hello, welcome to King David's Electrical. Today we want to look about direct online. So direct online is one of the ways of controlling motors. So first of all, before you start wiring, you must draw the diagram so that you can be installing from the diagram. So we start by drawing the diagram. We have here phase, which you can say it is live. So from the phase, we go to control fuse. From control fuse, we go to overload relay 9596 of overload relay. So 9596 are normally closed contacts of overload relay. And from that, we go to stop push button. Stop push button. Stop push button. So from stop push button, we go to open to start push button. Start push button is represented by this symbol. Start push button. Then at the start push button, we should connect the holding, because when the power will be going through the coil, it must be retained. So we must connect a retainer. The retainer will be connected to the normally open of the contactor. So we have normally open. We connect here normally open of the contactor. Then we connect this one to the coil of the same contactor. Coil live side will be A1, the neutral side will be A2. Then from this, all of them goes to neutral. So this is just a control system of a direct online controlling of a motor. So we are going to wire it according to this diagram. So first of all, we need to have our components here. So we are going to use this motor for demonstration purposes. This is a DC motor, and these are batteries. We are going to use them for the source of supply for this motor. So we have two motors here. We have this one and we have this fan. This is also a DC motor. So we'll use either of them for demonstration purposes. Welcome. So here we have a stop push button here. We are missing overload relay, so we'll go direct to the stop push button. So this is the main from the control fuse. It will go to stop push button, guys. So this is the main from the control fuse. According to our diagram, according to our diagram. So from the stop push button, we go to start push button. So we have a cable here running from stop to start. Then at the same time, we need a cable from stop to go to normally open of a contactor. This is a contactor. So we feed the normally open of our contactor 1314. Then output from normally open of our contactor is going to feed the coil direct. So from normally open of the contactor, we are feeding the coil A1. We are feeding A1. At the same time, the normally open output from the start switch also is feeding the coil direct, so that when we push the button and release, the contactor will remain intact. Okay, so we supply A1. After that, we look for the neutral to supply this circuit. The neutral supply. The neutral, guys. This will be our neutral from the supply. We put it direct to the coil A2. To the contactor, I mean, sorry. A2 of the contactor. Then we can try our supply if there is a source of energy before we connect the control. Polarities, negative and positive. So we can prove that from our source we have supply. Okay. Can also try with this, if this source can sustain our motor. Okay, it is also working. So we can choose either of the terminals. This is a contactor for three-phase motor, but for demonstration purposes we will use it. So we can choose either of two terminals to supply this motor. Let me take terminal T3 and T1. then from the source. Okay, let us press the contactor to test whether our connection is working for the power supply. It's working, guys. It is working. So the has been supplied, but you cannot continue pressing the contactor and releasing. So we have developed a mechanism in whereby if you press a push button, it will go on automatically. So let us try it, guys. Maybe give it supply. It's working, guys. This is a start push button. This is a stop push button. Start. The motor is running. Stop. The motor is stopping. Start. Stop. Now let me put it like this so that the camera can see it very well. So this is the circuit. Mains come from the fuse. It goes to the contact for the normally closed or stop button. From the normally closed, it supplies the normally open contact of a start push button. At the same time, the output goes direct to normally open of the contactor. The output of the normally open of the contactor goes direct to the coil of the contactor. At the same time, the output of normally open, that is start push button, goes direct to the coil. So when you push this button in, you energize the coil. But since you cannot continue pushing it in, you develop a mechanism to retain the supply so that the motor can continue running. So this is just a DC motor for demonstration purposes. These are two drive cells, 1.5 volts to drive this motor. So we can try this fan also if it can work. Just a moment guys, let me stop it. These are the supplies for the fan. Now we just change the terminals for this motor. Let me change the terminals guys. So let me press and see if the fan can get supply. It is getting supply. It's getting supply. Okay, let us also supply it through our control system. The same thing applies. You press the start push button, the fan is applied. The same principle. Press stop push button, it stops. Start, stop. Start, stop. This is a direct online control system. It is direct online from the name. You just apply the motor directly from the source. So there are some other control systems. We have forward and reverse, we have interlocking, we have star delta, but we go step by step. So today we just wanted to explain the direct online. You just supply the motor directly from the supply. So these two switches are limit switch, but you can modify. These components are very expensive, so for demonstration purposes, I've just used the limit switch. One of them has been used as a stop, one of them has been used as a start. So welcome to King David Electricals. If you have any question or you have anything you want to us to do practically, just comment, we will do it for you. Thank you and welcome. Thank you for watching.